Hello everyone, my name is Salom Sapkota and I'm a graduate student in Soil, Water and Ecosystem Services Department in University of Florida. I have put together this presentation to demonstrate the fundamental environmental science technique. Today I'll be explaining and walking you through the core method for measuring the bulk density. Uh, so this is a critical field and laboratory procedure used by the scientists uh, to assess the soil physical properties, pore spaces, and the overall level of the compaction at the given site. So moving towards the presentation, so at first we talk about the backgrounds and the project goals. So before we get into the field steps, why exactly do we care about the bulk density, right? So at first we need to understand what is bulk density. So bulk density is the mass of the open dry soil per unit volume. It is a direct indicator of how tightly the soil particles are packed together. As you can see in the diagram on the screen, so healthy soil has a uh, plenty of large macropores and small micropores. So this allows the water to infiltrate easily and provides the space for the roots to grow. However, when a site experiences, let's say, heavy foot traffic or the equipment use, then the soil structure is crushed. So those pores collapse and the bulk density number goes up and the roots become stone while water pools on the surface. So our goal with this project is to learn how to quantify that compaction so we can make informed land management decisions. Right, so moving ahead, talking about the project context, who, when, and where. For this specific project, I conducted a self-guided field demonstration to make sure the data would be scientifically valid. So I did not just wing it, I strictly followed the established standard operating procedures detailed by USDA, Natural Resource Conservation Services. Specifically, their technical notes on the soil physical properties. So I conducted my field samplings and measurements, and data collection took place in April 7. So for conducting this experiment of the bulk density, so at first I got ready with the different kinds of the instruments that are required to collect the samples. So these are the required equipments to conduct the bulk density study. So the absolute most important pieces of equipment is that the heavy duty stainless steel ring, because the bulk density relies entirely on the exact volume measurement. That ring cannot be dented or the wrap. We pre-calculate its internal volume using the classic cylinder volume formula. Alongside the ring, so we'll also need a slide hammer and a rubber mallet to drive it into the earth, flat blackened knife, and a trowel for sample extraction, and a heavy duty, let's say sealable plastics bag sprayed with the Sharpie marker to secure the samples and to prevent any moisture from escaping from the samples so when we get back to the lab. So once we are ready with the equipments, then we can go to the field and start our bulk density measurement work. So as you can see in the picture, now we are ready to begin the actual field sampling. Step one is the site preparation. So as you can see in the photo, we cannot just drive the sampler straight through the grass and the top debris. We need to clear away any loose organic matter, leaves or twigs that we call the O horizon or the duffs. So we want to measure the physical density of the actual mineral soil itself. So not just the compressible organic trash sitting on top of it, right? So using hand trowel, we carefully scrape the surface until the true mineral soil is visible, and we ensure the ground is flat and level before proceeding our measurements. So once the site is prepared, then we move forward with driving the core. So step two is driving the core. Once the surface is leveled, then we can take the metal sampling ring and place it vertically on the exposed soil. Then using the slide hammer or the wooden block or the mallet, we can begin driving the ring straight down. So now the next point is absolutely crucial for the grade and the data accuracy. So we must stop hammering the exact second the top edge of the ring becomes flush with the soil surface. So sometimes if you get overzealous and keep hammering, you are going to compress and squeeze the soil trap inside the ring. So that artificial compression will result in a false reading. So artificially high bulk density reading that ruins the whole experiment. Well, this is the point where one should be very careful while driving the ring or the core down. So once the core or ring is drive down, then we go for the next step, that is extraction and trimming. Once the ring is driven flush with the ground, the step 3 is the extraction and trimming. Then at this point, we want to take the shovel or the trowel and carefully dig around the side of the ring so that we can lift the ring without losing any soil from the bottom. So once we have pulled out the ring, then the real secret to accuracy becomes to play, right? That is the trimming. Take the flat bladed knife we had discussed earlier and carefully shave off all the excessive soils hanging or bulging of the top and bottom of the end of the cylinder by making the soil perfectly flat. This is very important to remember. Um, so and also there should be a guarantee that the volume of the soil we are taking back to the lab is exactly equal to the volume of the soil in that ring. So one stream, push the sampler into the plastic bag and seal it up tightly and lock in the filled moisture and label it with the site ID. So now we have collected the soil samples for the bulk density. The next step is moving forward with the laboratory analysis, right? The next phase is drying and calculating. So first we take the field moist weight of the sample, not just for our record, but to find the true bulk density, we must eliminate all the water weight. So we place the soil sample into the metal dish and put it into the scientific drying oven at 105 degrees Celsius for a full 24 hours. So after the 24 hours, we weigh the sample again and on a high precision analytical balance as shown in the figure, and this becomes the final dry mass. So to calculate the bulk density, we simply take that dry mass in the grams and divide it by the pre-calculated volume of our sampling ring in a cubic centimeter. So for the types of the silt, loam and sandy soils we find in these Florida regions, are typically healthy bulk density range lands somewhere between 1.1 and 1.6 per cubic centimeters. So in this way we can calculate the bulk density. So moving towards the conclusion and the summary, to conclude this presentation, measuring soil bulk density via the core method is relatively straightforward but incredibly powerful tool. It provides environmental scientists and the agricultural managers with a quick snapshot of overall soil health and physical structure. By comparing low traffic areas to highly compacted footpaths, as summarized in the table in the screen, we can clearly see the negative impacts of the human compaction on the root systems and the water flow. The biggest takeaway to remember for your own field sampling is that the careful trimming and extraction are mandatory. Any error in measuring the volume of the soil directly translates to bad data. Thank you all so much for your time and watching this demonstration. So for those interested in the reading and the extracts standard operating procedures I used or reviewing the data metrics for Florida soil survey criteria, I have listed my primary preferences here on the final slide. This concludes my makeup field trip presentation. Thank you once again.